So on August 17th, Fermi GBM saw what we call a short gamma ray burst. By itself, it wasn't anything impressive. It's like lots of events we've seen before. It was when we got the notice from the LIGO people, actually the email said, "Wake up." They had seen something too that made this so exciting.
There was a very clear gravitational wave signal in our data. And not just any old gravitational wave, but that of a binary neutron star, which we had never seen before.
And neutron stars are made of the densest matter you can have in the universe before you get to a black hole. So these are very exciting objects, and these are the objects that were predicted to produce the short gamma ray burst that we see with GBM.
This new way of learning about the universe is kind of like gaining a new sense. So it's as if we've been watching the news for all of human history, but the TV has been on mute. And now with gravitational wave detectors, we're able to turn on the sound.
I think what excites me the most about this discovery is that we're putting together traditional astronomy and the brand new field of gravitational wave astronomy to learn brand new physics that we couldn't do in any other way.
We do consider ourselves explorers. This is the very frontier of human knowledge. We're learning about fundamental forces in nature like gravity. We're learning about how the interiors of neutron stars, which are a very mysterious place, behave. We're learning about brand new astronomical phenomena in other galaxies. So we're right there at the edge, and because of this event, we've managed to make a significant step forward.